Hello guys, welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akin, your math instructor, and in today's video we're going to be extending our previous knowledge that we had learned on the channel here. We're going to be diving off into the fourth branch of transformation, and specifically we're going to be talking about the enlargement transformation. Of course, in our three previous uploads, you'd have seen where we spoke thoroughly and in depth about translation. We looked at reflection. We also looked at rotation. Reflection was done in part 1 and part 2. So was rotation, so forth. So we went through the whole aspect of the rotation matrix, the reflection matrix, the translation vector, and we definitely went through quite a bit. So of course, if you haven't checked those tutorials out, a link will be pinned in the description of this video or in the comments down below. You're going to find links to that particular tutorial, so it is highly recommended that you check out the tutorials on those three previous transformations. Of course, enlargement is in fact the easiest of all the transformation in terms of identification and in terms of application, right? So it's pretty simple. So hopefully I'll be able to go through this with you in part 1 and part 2. But of course, if this is the first time here on the channel, I do provide content that is related to the students doing exams on a yearly and a quarterly basis, where you find CSEC, CCSLC, SEA, EDXL, and GSEC exams. All right, so definitely that's the kind of content that I provide, but of course I spread my knowledge here wide and far, so this video will benefit you even if you are at the college level and you are trying to get some knowledge on the topic of enlargement. All right, so of course, if this is the first time you're on the channel, do not forget to hit the subscribe button below, turn on your post notification bell, leave some positive questions and comments down below, and do not forget to share this out to your mathematics community. All right, so let's get right into today's lesson. Here we go. So of course, guys, we're going to be talking about the topic of enlargement transformation, and let us start off as usual with the definition of an enlargement. Now, in the English language dictionary, enlargement means to get bigger. Of course, the word enlarge means to make something larger, but in math, enlargement has been extended to just not something getting bigger, but it also means that something can get a bit smaller. So we defined the word enlargement in math as a change in the size of an object. And so this change in the size of the object is as a result of a multiplier, or what we refer to as a scale factor, which we therefore use to represent by the letter K. So K represents the scale factor of the enlargement. Now, enlargement, as I said, extends itself to just the fact that not only can an object get bigger, but an object can also get smaller. And of course, basically when an object gets larger, we see that it's magnified, and when the object gets smaller in size, then we say it is reduced in size, or it undergoes a reduction. All right, and it is in fact the scale factor that is the cause of either of those transformations, reduction or magnification. Now, a magnification enlargement can be negative as well as it can be positive, such that the image can either be on the same side or the opposite side of the center of enlargement. So magnification and reduction has been broken up into smaller components, such as I said, negative and positive enlargement. All right, so we have positive magnification, we have negative magnification, we have positive reduction, we have negative reduction. So we're going to dive on into what is it that causes the object to be negatively magnified, positively magnified, negatively reduced, positively reduced. Now, it says here that similarly a reduction also can be negative or positive, with the image being on the same side of the center of enlargement. Now, before we dive off into the whole aspect of reduction and enlargement, and magnification, it is important that we note that just like rotation, the object has to be enlarged from a specific position. And for the fundamental basis of this, we're going to be enlarging our object mainly from the origin. But if you're interested in learning contents, learning more in depth about enlargement, like when we're enlarging an object from a point other than the origin, you definitely need to be subscribed to the channel so you can be notified whenever that video comes out in part 2. All right, now we're going to dive off then into saying here, when a negative magnification or reduction occurs, it will have the appearance of a magnified or reduced reflection. So therefore then, what you're going to find here is that, let's say that I have an object, which I'm going to be demonstrating to you on graph in a moment. Let's say that we have a negative magnification. What that means is that the object is going to magnify, but it's going to appear in an opposite direction, so to speak. So it's going to be turning backwards, or it's going to be turning upside down. It's going to be the complete reflection of its object, but just a bit larger, or perhaps a bit smaller. All right, so that's very important you understand, and in a moment I will demonstrate some graphical representation for you. Now let's look a little bit more into what is the scale factor. And as we had discussed earlier, we said that the scale factor is the multiplying constant that enlarges the object, which is represented by the letter K. Now, here is where we're going to be learning now, when is it positive versus when is it negative. Now, it says here that when K is greater than 1, the object undergoes a positive magnification. That means if K is 2, K is 3, K is 4, K is 5, and so on, then the object, the image is going to be K times the size of the object. Now, when K is negative, let's say here less than -1, then what you're going to find here is that you have numbers like -2, -3, -4. It's still a whole number, so it magnifies the object. However, the image is going to be on the opposite side of the center of enlargement. So therefore we say that it undergoes a negative magnification. Now, when K falls within a domain, let's say this domain here, this positive domain here, it says that when K is greater than 0, but at the same time K is less than 1, then a positive reduction has occurred. However, if K falls into the domain of -1, let's say here K is greater than -1 but less than 0, then we say that a negative reduction has occurred. In other words, just to simply put, if K is a positive fraction, that is a positive proper fraction, then the object will be reduced in size. And if K is a negative fraction, then we say that it also has been reduced in size but is a negative reduction. All right, so that was a mouthful of information. Obviously there's a lot of fundamental concept to learn about enlargement. All of this is necessary if you want to become an efficient student when it comes to the questions here given to you on this type of this topic here in math. All right, now we're going to go across here to the next page then, and we're going to be looking at some graphical representation of what is meant by enlargement. And here you can see that all my red triangles are my object. So in diagram 1 here, we're looking at this being the object. Diagram 2 here, this being the object. Here, this being the object, and over here also this red triangle here being the object. Now in diagram 1, as you can see as I zoom up the screen for you, it says here that basically what the image is demonstrating that the triangle ABC became a prime B prime, C prime, which is the image, but basically the scale factor is 2, right? So this is just basically me telling you that the scale factor is 2. That means the peach shaded triangle here is twice the size, right? Twice the size in terms of twice the length, and it's going to probably be 4 times the area. Okay, we're going to talk about that comparison between the area of an enlargement image compared to that of an object. We're going to discuss that in part 2. Now over here we see where a reduction has occurred. So my red triangle now became the peach triangle reduced in size. Notice that they are both on the same side of the center of enlargement. So when I mean by center of enlargement, it means that the object is being enlarged from this position here, and it is also being enlarged from this position here. And notice that both object and image are on the same side of the center of enlargement. Same here, reduction, positive number, they're on the same side of the center of enlargement. Now you realize that the center of enlargement then ends up between the object and the image. Now in this case here, this is as a result of the scale factor being negative. So it's negative 1.5. That means this image here is 1.5 times the image ABC here, the red triangle. But notice that the center of enlargement is in between. That makes them be on opposite sides of the center of enlargement. Same here, a reduction, negative 0.5, negative 0.5. The object has been reduced in size and they are on the opposite side of the center of enlargement. All right, and as I said earlier, the center of enlargement is the point at which the enlargement occurs. All right. Now here, what we're looking at is a diagram that basically shows you how to determine where the center of enlargement is. Now, as I said, for the purpose of part 1, when we're doing our demonstrations, we're going to be enlarging and we're going to be magnifying and reducing the size of the object from one specific position, which is the origin. But here are some examples where I'm showing you how it is that you actually calculate the center of enlargement. Well, how do you identify the center of enlargement when an object and its image is already given or already drawn for you? Now you'll recognize here that I have 2 straight lines here that are drawn from A connecting to the corresponding image point A prime, and so I have then B that is connected to B prime, which is 2 corresponding points on the object and the image. And then at the point where these 2 imaginary lines or these 2 constructed lines intersect, then you're going to find, boom, right here becomes the center of enlargement. All right, it's a little bit easier than that of rotation, because in rotation we spoke about bisecting these intersecting lines. So it's a little bit easier to find the center of enlargement as it is to find the rotation, the center of rotation. So definitely check out the rotation video on that. Over here then we're going to be demonstrating how do we do this. Notice that I've already marked the center of rotation, but you'll recognize that if we were to literally do this by ourselves, then let me just grab here, okay, same color. Let me just go here right ahead here and we're going to connect, say here C. Notice that I'm drawing a straight line here to connect to C prime, or C to C prime, and then we're going to say here draw A here. Notice that it goes right through automatically once I draw the straight line towards here, boom, like that. So you see that already the center of enlargement is located at the point 5, 5. All right, similarly here now we're the one that is doing it. It's a little bit more because they are basically in a straight diagonal to each other, right? Then drawing straight lines pretty much just connect. Say here we connect B here, it's going to automatically go through A and connect to here, but we have to extend it. Okay, we have to extend that line. All right, so sometimes you have to extend them on both ends. And then say here that you connect C then to C here. Notice that we don't know where it's going to meet, so we have to extend it here, boom, like that. So you see that that's a little bit not so straight, guys, but you get the idea that if you use your ruler, you're going to be going through that point here. All right, and here's a more example of what we're going to be doing. Here is where we are going to be enlarging the object, okay, from the origin. Now here you can see that I have a green triangle on the top here, and we have a blue triangle here, and we connect. Notice that I connected C prime to C. I connected A prime to, let's see here. Okay, pardon me. All right, hold on, guys. So I connected C prime to C. I connected A prime to A, and then you're not seeing it here, guys, but you can see I connected B prime down here to B, and they intersected at the point 0, 2. All right, so all of these here are showing you that the enlargement is not always from the origin, but it can be from the origin. It really just depends on the question. All right, already, guys, if you're getting some value, do not forget to hit the like button, and of course, before you leave, ensure that you leave some positive questions and comments down below. Now, we have been hinting at the center of enlargement, but what exactly is this? Just by my own definition here, it says that the center of enlargement is a specific point at which the object is enlarged from, which is a 1/2 matrix, which is, of course, in the form here, AB. Most times, this point is at the origin, but of course, can be anywhere on the plane. You can either be given this position to draw the image, or it's a possibility where you might be asked to locate the position that we just demonstrated earlier, given the drawn object and image. And just by doing that, we basically draw 3 or 2 corresponding points connecting the object and the image. And at the point where the extension lines intersect, then that becomes your center of enlargement. And all of these diagrams here are the diagrams that are demonstrating to you exactly how this is done. So we're going to be giving it a try in this particular video, but you guys can give it a try as well on your graph. All right, beautiful, beautiful, wonderful. Let's get into the next segment of this then. So we're going to be looking then now at the enlargement matrix equation. How do you actually calculate? What's the calculation process like for finding the image of an object that underwent, a magnification or reduction? So we use a very simple formula here, E multiplied by O. I tend to use like a sub M here, that's enlargement matrix. Okay, so enlargement, which represents the matrix, times the object is equal to image. Very similar to that of reflection and rotation, all right, but much simpler. So that is the enlargement matrix multiplied by the object point that equals to the image location. The enlargement matrix is a 2/2 matrix in the form, say here, K0, 0, K. So this, what I would call here, this is the leading diagonal. The leading diagonal of this matrix here is where our scale factor will represent, and our non-leading diagonal here is always going to be 0, 0. So it's always going to be K0, 0, K. That means if the scale factor is 2, then the matrix is 2, 0, 0, 2. If the scale factor is -3, then it is -3, 0, 0, -3. If the scale factor is 1/2, then it is 1/2, 0, 0, 1/2. And if the scale factor is -3/4, it is -3/4, 0, 0, -3/4. They will therefore then use the point. We'll therefore use the matrix and multiply whatever point or points that makes up this object to then produce the image. And that is, of course, the traditional row by column. All right, and it's a very simple way to go around the whole row by column. Whatever the matrix is, you're just going to either double it, triple it, or you're going to find a fraction of the entries inside the matrices. All right, now we've been doing a lot of theory. Let's get into the practical application of this. Then I have a question here for you that we're going to be walking you through. All right, so here we go. It says here that given that triangle AFG has coordinates E -3, 1, F is -2, 4, and G is 2, 2, undergoes an enlargement of scale factor 2, comma, -2, comma, -1/2, comma, and 1/2 about the origin. Okay, calculate the coordinates of the images and draw each on the graph. Now, for the purpose of exams, they're not going to ask you to do all 4. they're just going to ask you to do one. All right, but the idea is that it's a complete tutorial, so I want you to be able to see what all the images are going to look like given this. Now prior, I would have shown you drawn up images already, but we're going to get tangible with the question then. So let us start out by plotting our point, -3, 1. So let me just grab here. Okay, beautiful. So we have -3, 1. Okay, let's just look at the points. -3, 1, -2, 4. -3, 1, -2, 4. -3, 1. So that is 1, 2, 3. -3, 1. -2, 4. So that's -2, 1, 2, 3, 4. All right, so that's my point here, and this is my point E. This is my point F, and I think G was 2, 2. So that is 1, 2, 1, 2. This is my point, see here, G. All right, let's just confirm. Okay, let's just confirm what the points are. Okay, so G is 2, 2. And so what we're going to be doing here is that we're going to be connecting these points here. So we're going to connect this to this here. Then we're going to connect this to this here. And then this to this here. Students, it would be very nice for you to actually be doing this with me. And then you're going to be matching your solutions with mine. All right. Watching me do it is good, but you have to literally be doing this by yourself, and you have to search for questions on your own that you can also become efficient at this. All right, so next then we're going to be enlarging the object. All right, I'm going to be doing some of my calculations here in this corner of the graph. Okay, so what this means then is that I'm going to be using the formula here, E multiplied by O equals I, and the E stands for my enlargement metric, which in this case here they say first of all is 2, so that's going to be 2, 0, 0, 2, and then that enlargement metric will multiply the object points that I have, and the object points that I have were -3, 1, -2, 4, and I believe it was 2, 2. All right, let's just confirm that. -3, 1, -2, 4, and 2, 2. And that's what I have here. And so basically what we're doing is that row by column is going to give you the same result as if you're just doubling the numbers at the top. So here we have 2 times -3 is -6. Okay, then you have 2 times -2, that's -4. And then you have, oops, what am I doing with a comma here? There's no comma needed here. And then we have then 2 times 2 is in fact 4. Okay, all right, let's just fix this. And then now the bottom ones then are going to be 2 times 1 is 2. Then we have 2 times 4 is 8. Then we have 2 times 2 is in fact 4. So we're going to be plotting the points downwards, okay? Because this becomes then my E prime, my F prime, and my G prime, okay? All right, beautiful. So then we're going to plot -6, 2. I may have to, let me just write the points over here, guys. That's E prime, F prime, and G prime. Then we're going to have -6, 2, -4, 8. And then we're going to have 4, 4. Okay. And then I'm going to have to erase here because I think I'm going to need a space for this. All right, so then let's plot. So -6, 2, so that's -6 up 2 right here. And then we're going to have -4, 8, so that's -4 right here. And up 8, 1, 2, 3, 4, 5, 6. Got to zoom out my screen. Let's go again. So that's -1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So that's up here. Okay, that's my F prime. This is my E prime, okay, and then we have 4, 4, so that's going to be 4 this way now. That is 1, 2, 3, 4, 1, 2, 3, 4, okay, and that's going to be my G prime. So I'm going to use a different color ink here to overlay this. So then we're going to have here boom, like that, and we're going to have C like that. We're gonna have C like that, and so my object has been magnified by the scale factor, say here 2. All right, so I hope you got that little calculation there. So then let's just erase this here. Then we're going to be looking at enlarging the object, say here by -2. So it's going to be the same calculations here. All right, so I'm going to have then -2, 0, 0, -2 multiplied by my original points, which were -3, 1, -2, 4, and 2, 2. And then by doubling these points now, basically I'm going to be magnifying the object negatively. So that's -2 times -3, that's -6. Pardon me, whoops, that's +6. And -2 times -2, that's +4. And -2 times 2 is -2 then. Then we're going to end up with at the bottom here, -2 times 1 is -2. Then we're going to have -2 times 4 is -8. Then we're going to have -2 times 2 is in fact -2. All right, so we're going to write these points up here. So that's going to be 6, 4, 4, -8, and -2, 2. All right, and that's going to basically be my object points. Let me just erase this calculation down here. All right, beautiful. So then we're going to go ahead and plot our points. So that's 6, 4. So it's going to be 6, 4. Let me double check on that. I think I made a mistake. Let me just double check this, guys. That's -2. Hold on, guys. I think I made a mistake here with my point. I think my original point for E was -3, 1. Okay, so this is supposed to be 6, -4. My apologies, guys. So 6, -4. So that's 6, 1, 2, 3, 4. That's my E double prime. Then we have 4, -8. 4, -8. So that's going to be 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. That's my F prime. F double prime. And then I have -2, 2. So that's -1, 2, 1, 2. I think something is wrong, guys. Hold on, give me a sec. Alright, guys, so I did make a little error here. My correct points are in fact 6, -2. I actually have 6, -4 here. So it is supposed to actually be, after I did my calc, 6, -2. Then I'm supposed to have 4, -8. And then -4, -4. Not sure what happened here, guys. I think I was lost a little bit of concentration. But then let's go ahead and plot, say here. And 6, -2, so that's 6 out here. -2 down here. Oops, in the wrong line. Right here. Then we have 4, -8, so that's 4, 1, 2, 3, 4, 5, 6, 7, 8. That's down here. That's much better. So that's my E. That's my F. Double prime, and then my G is -4, -4. So that's -4, -4. So I need to erase this calculation here. Gotcha. So that's 1, 2, 3, 4. 1, 2, 3, 4. All right. That's my G double prime. And so when I connect this here, you see that this white triangle here, let's use a different color, not for white, let's do yellow. Okay, so connecting here, you can see that this triangle here is a complete reflection of the white one there, but just bigger on the other side. All right, so we just have to just be a little bit careful and be very process oriented with this. It's just a simple case of just doubling our points and we get a beautiful image there of that white triangle. Now let us go ahead and reduce the object then. All right, so now we're going to be looking at, say here, a half. Okay, so let's see if I can get some space here. So that's going to be a half, 0, 0, a half, multiplied by, see, the points that I had was minus 3, 1. Then we have minus 2, 4. And then I have 2, 2. Okay. So when I double those points, when I cut these numbers in half, I'm going to get a half of minus 3 is minus 1.5. A half of minus 2 is minus 1. And a half of 2 is 1. At the bottom, a half of 1 is a half. So that's a half. Pardon me. So that's a half. And a half of 4 is 2. And a half of 2 is 1. Okay, so then by plotting these points, then let me just grab, say here, pink. Okay, so negative 1.5 up a half, so that's left negative 1 point, so that's negative 1.5, and then up halfway, so I'm right in between this box right here. Okay, I'm right in between this box right here, so that's 1.5 a half, right, this position here. All right, and then we have negative 1 to my left and 2 up, so that's negative 1 to my left and 1, 2 up, so I'm right here. Okay, and I'm also right in the center here. And then I'm going to be, say here, 1, 1, so that's going to be 1, 1 right here. Okay, and that's going to be obviously my my E, call that triple prime. Then I'm gonna have my F triple prime, then I have my G triple prime, and when I connect this here to this, I get a reduced enlargement. Okay, beautiful. And then obviously then when the scale factor becomes, say here, negative a half, then I'm going to get the same points, so that's negative a half, 0, 0, negative a half, and then I'm going to multiply by my original points that I'm going to be magnifying or reducing. In this case I'm reducing. This minus 3, 1, minus 2, 4, and then of course 2, 2. When you go negative a half, you're going to get 1.5, negative a half. Okay, then I'm going to go 1, so a half of minus 2 is negative a half of minus 2 is positive 1, and negative a half of 4 is negative 2. Then of course you're going to have negative a half of 2 is 1, pardon me, so that's negative a half of positive 2 is negative 1, and negative a half of 2 is of course negative 1. Okay, so that's what I have then. So 1.5, negative a half, positive 1, negative 2, negative 1, negative 1. And if we plot that, then let me just use the same color here. So 1.5 a half, so that's 1.5, 1.5 here, and down a half I'm going to be right here. And then I'm going to have 1, negative 2, so that's 1, 1, 2 down here. So that's my E IV prime. Okay, then I'm going to have my F IV prime, and then I'm going to have finally then negative 1, negative 1, so that's negative 1, negative 1 down here. I'm going to have my G IV prime, that's my fourth image. So I'm going to connect here and 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 here. All right, and what you're seeing here on screen is an example of an enlargement occurring from specifically here the origin. All right, so that's my origin. So hopefully you guys actually got a hang of that application. And then, as we had mentioned earlier, how to find the center of enlargement, we are going to therefore then connect two corresponding points, and at the point where the points intersect, right, we are going to find the center of enlargement. We didn't do that, so we could actually do it here. Okay, so a little bit, I don't want to mess this graph up, but if you can use it, if you have your graph, take your ruler and draw a straight line connecting F prime to F triple prime to FIV prime, and you recognize that all 3, 2, 3, or all 4 lines are going to be passing through this position. Let me know if you were successful in the comments by doing this. All right, and you can make up your own questions as well, guys. You can just pretty much make up some points, ensure that it creates some sort of shape, and then you can enlarge the figure by, say, scale factor 3, scale factor 4. For the purpose of the graph paper though, if you're going to increase your scale factor beyond 2, you may have to change the scale. You may not be able to use a 1-to-1 scale, but you may have to use a 2-to-1 scale or a 3-to-1 scale, so it really depends. Alright, and so you can definitely just connect those corresponding points to find the center of enlargement. Alright, and you can actually demonstrate it here as we have seen on screen. Alright, so that is pretty much it for this particular video tutorial on enlargement part 1. In part 2, we're going to be looking at how to determine the scale factor. Definitely something a little bit too much for this video, but we're going to be looking at how to determine the center of enlargement and how to enlarge an object when the center of enlargement is not the origin. This is going to be an interesting video, so definitely stay tuned for that one, and hopefully this tutorial was of benefit to you. So without further ado, let's bring this video to the end. I hope that you enjoyed and you learned something valuable. Until next time, this is your math instructor Akin. Keep on practicing and keep on improving your skill set in transformation. Until next time, take care. Bye bye.